Hello, dear professors, honorable chair of the conference. I'm extremely grateful to participate for the second time at this conference, and I would like first to dedicate a special thanks for your time devoted to lead this conference under the best circumstances and for giving us the chance to expose our works. Please let me introduce myself. I'm ELMOUZOUN Mouad, a PhD student at Hassan First University of Stad, Faculty of Science and Technology, Radiation Matter and Instrumentation Laboratory. My work's title is shown here, a novel hybrid model for the detection of driver's drowsiness based on the EEG signals and personalized extraterrestrial classification under the supervision of Professor HARMOUCHI Mohammed and our laboratory team. Our plan is as shown. We will start with an introduction, followed by the problematic, the state-of-the-art study. Then we will expose our proposed method, where we will show our results obtained, and finally a conclusion. First of all, we will look closer to our brain activity. So what is the human brain activity? Which is simply a huge number of electrical signals fulfilling our heads. So every thought, every movement, every eye blink, every feeling is just the translation of our brain signals. And while driving, a complex set of our brain signals is established, which can cause drivers to feel tired and even more so to feel drowsy and sleepy while driving, leading to dangerous and deadly accidents. Another factor that can make the driver feel sleepy, which is the monotony of the highways and the aspect of traveling long distances for many hours. In Morocco, the deadly accidents in highways caused by drowsiness behind the wheel reached 33.33%. In other terms, 1 out of 3 fatal accident frequency. This has given us the reason to think about the resolution of this tragedy and makes us ask ourselves what kind of method can we develop to avoid these accidents, and what are the most significant parameters that we can use to achieve our main goal. So after analyzing the problematic, the idea was to develop a system that can detect automatically the driver's state of drowsiness, which is the state of transition from the normal and awake state to the foreign sleep state. Furthermore, the idea of this system is not new, but it will come to resolve the limitation of the existing systems and to show the highest performance of our method. Our work is therefore to develop an intelligent method for the automatic detection of driver's drowsiness based on the analysis of the electroencephalogram signals, EEG signals, using a personalized, efficient machine learning method. Before all, the first step we have took is to focus the study on similar systems already realized with the same or different technologies and to extract and identify their limitations. The system on our left is a smart glasses for the drowsiness detection. It works by inspecting the frequency of the eye blinking due to an infrared sensor, also detecting the microfolds of the head using an accelerometer, just like the cap on our right, but that's not enough to judge a driver's drowsiness state. And the limitations are shown here. They are based just on microfolds analysis and no physiological parameters, and they have the lowest detection efficiency. The systems here in this slide are based on the facial recognition of the driver using different algorithms. The system on the extreme right is also based on the same technology, but instead of using a simple camera, they use an infrared camera to inspect the respiratory frequency by capturing the temperature at the undernose region. We cited here some limitations where we can find that the results are not in real time because the detection can take several seconds to reply, which puts the drivers in danger. And also the systems are weak and ineffective in the absence or lack of lights. And in some head and face orientations, the detection of the face or eyes regions is not possible. These following systems is the one used in our work and the most important and efficient. which is based on the analysis of physiological signals that are the EEG signals, and especially a single channel for our method, which is the FP1 reference channel. We use this channel because different studies show that the FP1 location of the electrode is the most used in this type of research, showing a high correlation to drowsiness detection. The first step of our work is the signal acquisition, or the phase of preparing the dataset. Then the pre-processing and filtering to eliminate the noise while the recording process. Then we have prepared our main processing algorithm containing the whole analysis, the features extraction, the features selection, the training, the testing of the classifier, and finally the display of our prediction results. So our method therefore is summarized in the following flowchart. Before presenting our results and our analysis, so we will present the reason behind getting the best performance. First of all, the most important aspect is the data preparation. If the data is well chosen and the features are extracted from this data and fed to the classifier, it's very sure that we will get significant results. So this figure shows the distribution of the features extracted from the two classes, awake and drowsy. We remark very clearly that in this graph, the features are very well divided and split into two classes, the drowsy and the awake class. Here in the following slide, we are showing our results obtained. The table on the left shows the different classifiers we use to train our model, where we use 7 classifiers for our hybrid analysis, mixing the 3 domains, time, PSD, and FFT. We can clearly notice that our hybrid model using the extra trace classifier reached the highest accuracy, which is 98.4%, and the best processing time consumption, which is up to 1 second, compared to our last optimized decision tree model. And here on the right, a screenshot of our output of the model from the Python IDLE used, showing the whole confusion matrix results. To situate our work, the following works used a single channel study in addition to using the same dataset of the EEG signals, which is the PHYSIONET database, in order to compare our results and show the improvements added by our hybrid method. In the work of Belkhdar, for example, in 2018, they proposed a method of analyzing the spectral domain of the EEG signals under MATLAB by applying the Fourier transform and a classification by ANN, artificial neural network. With this method, their work reached an accuracy of 88.8%. The highest accuracy of 94.45% was reached by Shinara and his team in 2021 after using a processing method based on the wavelet packet transform WPT and the extra trace classifier. The proposed work aimed to improve the efficiency of our last algorithm based on the optimized decision tree of detecting drowsiness. So we improved our last results in terms of accuracy and rapidity. So we reached the 98.4% using the optimized extra trees. So we extracted a total of 8 features from the 3 domains, the time, the Fourier, FFT, and the PSD, power spectral domain. After that, we trained 7 machine learning models, SVM, GP, KNN, MLP, decision tree, optimized decision tree, and our personalized extra trees classifiers. We compared our work to previous ones based on the same approach and same database. So we showed the added value of our model which is the improvement of the detection performance in terms of accuracy, which achieved 98.4% and a processing time up to 1 second compared to all our performed models. So this is the bibliography that we used, and thank you for your attention.